Okay, welcome. Today we're going to be looking at a number of different shapes of the arch and thinking about what are the similarities and differences to the Roman arch we saw, and then also similarities and differences to the different variations. So we'll be comparing them amongst themselves as well. But then also, what are the weaknesses of these shapes? What are the strengths of these new shapes? And we'll notice that some of these arches are going to be more decorative. Some of them are going to be more functional. We're going to try and keep an eye on that kind of thing. So let's get going into that. All right. So variations of the arch, and here we go. Okay, so this first one is a Gothic or pointed arch. And a little difficult to see in this one. This one's constructed of brick. So the arch stones tend to be pretty small. But you can definitely see them, right about here. They start tilting. Right about there, they start tilting up to form this pointed arch. Now the main thing here is that what a Roman arch would do is it would form more of a shape like that. So more of like a semicircle near the top, or a half circle near the top. This one it has a pretty similar curve, but it goes more to a point at the top. Now, one of the things you will notice about this type of arch is that point allows for sort of taller, more impressive openings, but not necessarily as wide. Now, depending on, you can make them as wide as you want, if you had the building materials be stronger. But basically, it's going to be taller for a given width. It's a good way to put it. Now, another thing is that, in this one, you can kind of see they did do this. They did have material on top of the arch. But one of the things that the point is going to do, it's not going to be as load-bearing as a Roman arch. It's going to be a little bit more difficult to keep that pointed shape and still be able to have this arch support different structures. So you'll be noticing that when you look at pointed arches, particularly when we start looking at Gothic architecture, that the pointed arch tends to be a bit more decorative than functional, although it does still have a specific function. So we look at another one like this. Again, this one is load bearing, and there's one feature here that I did want to show you, and that is these pointed arches tend not to have a keystone. What they do instead is they let the two top stones sort of lean against one another, and together they form a kind of keystone. But basically, because it's coming together more like a triangular arch, rather than having a stone at the top, they're kind of letting them lean together like the points of a triangular arch would. So that's something to keep in mind about the Gothic arch in particular. And like I say, you will see a lot of Gothic arches in medieval architecture and particularly in medieval churches. So there's the diagram, and like you were saying, like I was saying, you can see the fact that there's not a single keystone. There's these two stones leaning together that are serving essentially a similar function of the keystone. The problem, I think another reason for this is that having two stones allows you to get that pointed shape without necessarily making, a single stone that was shaped like this. And we might be able to do that fairly reasonably with concrete. If you're trying to find a stone, shaping a single stone like that might make it weaker. So maybe it's just better to have two stones like that. Now, like I say, This is not going to support. You're not going to flatten this top out so it can support loads quite as much as you might with the Roman arch. Another thing to notice here is that these curves are much closer to being straight up and down than they were with the Roman arch, and that's going to give them a certain amount of they're going to behave a little bit more like posts. than the Roman arch is the idea. So you'll tend to see these you'll tend to see these types of arches on taller posts than you would the Roman arches. Now that when you put them on taller posts, as we saw, one of the weaknesses of putting arches on posts is that the post tends to tip over easily, and that is one of the reasons why you won't see these arches getting very wide. So that's another thing to keep in mind about the Gothic or the pointed arch. So we'll go on to the next one, the Horseshoe Arch. Now the main thing to notice about this one, it's quite similar. You can see the keystone right about there. That would be the keystone. But it's quite similar to the Roman arch if we just sort of take this shape. But one of the things that the keystone arch does is it kind of makes it more of a circle, so more than just a half circle. So it kind of looks more like a horseshoe. And then a lot of times what you get is you get that kind of curving back outward in one of the stones. Now, this is going to have a lot of the same strengths and weaknesses as the Roman arch. It'll be pretty well load bearing as the Roman arch. The main weakness, I think, is going to come in these stones down here. Because as we know, a whole bunch of the force is pushing, outward to either the left or the right, depending on the side of the arch. Now, with when you have just the posts directly, you can kind of get a little bit of there's a little bit of force pushing down into the posts. But when you're kind of having these larger pieces of the arch, try and force the arch to come back in, that's going to be, come back in towards the center, towards this way. That is going to make it somewhat weak, which means, as you'll see in this arch, and with a lot of these arches, you're going to need a block to prevent the arch stones from sliding out in that area. So the weaknesses are not that much different than the Roman arch. It's sort of a stylistic thing. In this particular one, you can see that I think they're actually using this stone lintel as sort of another way to support some of the stuff that's above, and to make it so it's not quite as much outward strain on those arches. So they're kind of using this, I would think, almost like a roof truss uses it to prevent the outward sliding of the arches like that. So that's a thought to notice with the horseshoe arches. Look at another one here. Go to the next one. And this one's a little bit bigger. And what you will see, another thing you'll see is that for the most part, these horseshoe arches tend to be a little bit more standalone than the Roman arches tend to be. So they get a nice big round opening, which can be very impressive. But you tend not to stack them side by side like we saw with the Roman arch, with the Roman arcades. So tend to be more for making doors and things like that. The main features, again, to notice about the horseshoe arch is that towards the bottom here, rather than having it just end right at this point, which would make it very similar to a Roman arch, you kind of have the arch stones continue down back towards the center. Now, again, that's your weak spot is really going to be right in these two areas where that arch starts to kind of curve back towards the middle. Because, again, we saw that the way the arch is going to fail, all these stones are going to be being pushed outward, and this is the point where, these stones are really trying to get pushed outward, but these stones below them aren't doing anything to prevent that. So basically, it's just going to be the friction of those two stones, and then, whatever support you have off to the side here will prevent those stones from sliding out. So that would probably be the main weakness of the horseshoe arch diagram. Okay, so this is an Arabic arch, and you'll notice it's going to be very similar to the pointed arch. But with a lot of the Arabic arches, a little difficult to see in this one it'll almost be like a combination of the pointed arch with the horseshoe arch. So this Arabic arch does kind of go into a straight down position, but a lot of times what you'll see with the Arabic arch is it will start to curve back towards the center, but instead of being perfectly rounded at the top, it comes to the point like a Gothic arch does. Now, this one's kind of interesting in that you can notice that this keystone does have a bit of a funny shape there. So notice it is a little different than the pointed arch where you didn't have a keystone, but it is a lot smaller because they did, take that little notch out of the stone in the bottom. So you can't make the stone super big because that is a weak spot in the stone. Here's another example of the Arabic arch, and you can see the keystone up here. Again, a smaller keystone. This seems to be made a bit more of brick. And even with this one, it doesn't really curve back into it. So these two have been kind of similar to the pointed arch. The main thing I would say is that the Gothic arch would kind of come up like this. The Arabic arch starts out a bit wider and then comes to a point. So maybe it's more similar to sort of a triangular arch made with arch stones. Like that seems to be kind of the aesthetic they're going for, to make a kind of triangular shaped archway, but without just a single stone, and taking advantage of the structural benefits of the arch. All right. So this one I think is one of my favorite types of arch. This is a flat arch. And this arch really just consists of 3 stones. And you might say, oh, it's just a post and lintel, really. But what it's doing is it would be a post and lintel if this was all one piece. But as a reminder, one of the drawbacks of the post and lintel faces is that there's a lot of is that when you start pushing down on the center of the lintel, and even under its own weight, it can start to flex in the middle. When it does that, it has tension at the bottom that makes the stone weaker and much more likely to crack. The flat arch is basically a way to get around that. So instead of having a long stone piece, what you do is you break it up into smaller pieces and then put a keystone into place there. Now this time, the keystone is small enough that it's not going to flex. Basically, it's gonna be pushed downward. But again, the principles of the arch are going on here, and that in order for the keystone to push downward, it's got to push these larger stones to the left and right. Now, this makes it really, really important that for the flat arch, that it be strongly supported off to the sides. So it's really, if you want this flat arch to work, you've got to really prevent the side stones from sliding to the left or right. So, and the other thing is the arch has to be very tight. So if there's any sort of looseness in this arch, and this arch can start to, if the stones start to wiggle at all, and they start to break free, then the whole arch could come collapsing down. So that's one of the things to keep in mind with the flat arch. Another example of the flat arch, you have the keystone right there. This one right here is probably a little more decorative in that it's made entirely from brick. But you can definitely still see the standard features of the flat arch there. And again, you wouldn't combine this arch with multiple arches. It would more be, you wanted something similar to a post and lintel, but you wanted to take advantage of the structural benefits of the arch. So there would be the diagram of the flat arch. And again, we can see that for the keystone to go downward, it's got to basically push this arch to the right. Now, the other thing to remember is that all of these stones are being pulled downward. So the main idea is that they've got to push all the other ones to the left and right. Now, the main problem I mentioned with the flat arch is that none of the stones next to it, or very, very little of the stone to the left or right of the keystone is doing anything to support it from going down. It's basically the only thing that keeps it from going down is the fact that these stones are wedged together so tight that none of them can move. But if they can move even a little bit, there's no, like this stone, we'll label them, say stones 1 and 2 to the left and right of the keystone. They're not providing much support for the keystone from underneath it, and that was not as true with some of the other arch designs that we saw. Okay, and here we are looking at the parabolic arch. Now, one of the main things I was hoping you would notice about this arch and the next arch is there's no sort of posts for this arch. The arch itself continues all the way into the ground, so we're seeing that we have sort of this arch shape all the way through, as opposed to having some columns here that the arch would rest on. Now, the main advantage of this is that the arch shape continues all the way through, and thus you get this constant arch support all the way into the ground. The drawback is that you have to have, you have to have this parabolic shape all the way through. So a lot of designers thought it was more impressive to have the arch sitting sort of on top of these longer columns. It would give the appearance of a larger, more narrow, elegant sort of feature than having the arch shape go all the way through. But the main advantage is that it is going to be a heck of a lot stronger. So the parabolic arch is one way in which we do this, and you probably notice it's very similar to the next variation of arch, the catenary arch. The main difference is that they're just really slightly different in shape. Parabolic arch is shaped like a parabola, so for those of you that have gone through some graphing of this formula, y equal x squared, that generates a type of parabola. This would be a down parabola, so you'd have like a negative x squared on that. But that is that's the parabolic arch shape. You've got another example of it here, and you can even see with this one. The stones sort of, like, you can almost use rectangular stones because towards the end of the arch you've got almost a straight line, but as you get up towards the top of the arch you have to use smaller and smaller stones because that is where the curve of the arch is, and tends like I said to be a fair bit stronger. And it really does sort of take away some of the weaknesses of the Roman arch, because you'll notice that what's happening here is we have a similar sort of thing going on at the top, in that the keystone, actually let's go to the diagrams, look at this. The keystone wants to come down, but in order to do this, it's got to move this guy to the left or the right. Now, the key is that whoops, I wanted to go back. The next arch is going to be doing the same thing. Now, what you'll notice as these stones get lower and lower and lower, the goal here is not to make it go vertical like it was with a standard arch, but it's to kind of give it some of that support so that it's constantly pushing, back towards the center on the stones of the arch that are bearing a lot of the weight. So basically, the fact that this isn't going into a perfectly vertical column, it's taking away one of those weaknesses we saw where the column and those stones near the column were the first place to collapse on the Roman arch. And we'll talk about why that is when we look at the catenary arch. That's a catenary arch. Looks very similar to a parabolic arch. With this one, we can kind of see that they have made the base a little bit more massive. But this is basically a catenary arch that's just standing on its own, kind of like we saw with that Roman arch with the very small stones. And again, it's got similar features as the parabolic arch, where these stones kind of in this region, their whole point is to, be able to provide a little bit of of support that keeps those upper stones from sliding off to the right. Because we saw that's what those upper stones kind of want to do. That's going to be their tendency when they're loaded down. Very famous catenary arch, turns out it's very good to use in steel, is the Gateway Arch in St. Louis, Missouri. So again, very similar sort of shape to the parabola. It's not actually a parabola, which is why the arch is different. If you wanted to know the exact function, it is called a hyperbolic cosine. And why it's a hyperbolic cosine is slightly a bit a more difficult question, so I won't go into that too much. But the arch shape itself is very strong. I'm going to talk about why that's the case. Basically, what happens when you hang like a chain or gravity or a rope, sorry, just in normal gravity, and you have the two top ends supported, it forms this kind of U shape. And it turns out what that is exactly the same shape as a catenary arch. Now, what this means is it basically means that no part of this arch is under sort of more there's no real part of this arch that is weaker than any other, right? Because if there was, in the chain shape, it would just rearrange itself so all the chains had sort of the same or the strain on each of the chain links had been equalized. So that's the idea, is that gravity naturally forms a chain into this shape. So if we want to get the strongest shape we can, if we want to, support something, we use this catenary shape, which turns out to be exactly the same shape as a chain would make when it's being suspended upside down. And this makes this shape of arch, exceptionally good for things like bridges. Now, most of them are not this high. Most of them would be like if we took this chain and we move this end way over to the left, so it would look more like this, and then we flipped that over. But that is still a catenary shape, and it's still one of the strongest shapes that you can make. So if you see arches on bridges, that is going to be the reason they're gonna be in this catenary shape as well. So, like I say, very similar to a parabolic shape. It has a lot of the same benefits in that these stones down here are basically, I guess there'd be wooden blocks in that one, but they're basically providing the support that is pushing these ones back up and to the center. And again, these stones, they kind of want to go out, but instead of just resting on vertical pillars, they're resting on these slanted pillars that are providing some of that support. So that's the idea behind these variations of the arch. Okay, so that is about it for this one. So what we are going to be doing next time is what you're going to be doing. You'll be looking at some extensions of the arch. So take a look at the way that different arches are combined. And a lot of times, these, you'll see them combined in these different ways, using different variations of the arch that we've just now observed. So thank you for tuning in, and I will see you next time.